Einstein's ultimate dream was to come up with one equation that could describe the entire universe. An equation that would describe everything from the very smallest atoms to the very largest galaxies. He never got there, but he did establish his theory of general relativity, one of the two theories that can, together, describe the universe. Einstein had noticed, like many others, that Newton's law of gravitation was not entirely accurate. For example, Newton's law could not explain Mercury's path through the sky. So in 1907, Einstein began working on a theory that would describe gravity. He started with a thought experiment where he realized that observers would not be able to distinguish between an accelerating reference frame and gravity. What this meant was that if an observer in a rocket accelerating at 9.8 meters per second square dropped a ball, he would not be able to differentiate the ball's motion in the rocket from the ball's motion under the influence of gravity. From there, it would take 8 long years of hard work before Einstein eventually finished his theory. The result was arguably the closest anyone has come to describing the universe with one equation. But the equation is not the best part of Einstein's theory. Einstein's theory came with a free visual, and that visualization is truly genius. Einstein not only described gravity, but he also did what Newton had failed to do. Einstein told the world why gravity exists. Newton had no idea why apples fell to the ground, and so he called it a force, gravity. But it would take 228 years before finally Einstein explained why gravity attracted things. So this is how Einstein set about describing gravity. First, he said that the world was not just made of 3 dimensions of space. He combined space with the dimension of time, creating a 4-dimensional model of the universe, space-time, establishing the fact that space and time were closely related. Now Einstein said that space-time could be deformed by massive objects. The heavier an object is, the more deformed space-time became around that object. Einstein described gravity by saying that any object would follow a straight line in the curved, deformed, 4-dimensional fabric of space-time. But from our 3-dimensional view, the same object seems to follow a curve towards a massive object. Except Einstein was better than most of us at physics, so he did more than just explain a visualization. Einstein developed an equation that described the motion of objects moving due to this curvature of spacetime. Today, Einstein's theory of general relativity is the best theory we have for describing gravity, and it is consistent with all observations. General relativity is now used as the basis for cosmology, and probably will for many years to come.